So hi everyone, my name is Austin Blackstone. I'm a developer evangelist for ARM Mbed. Yes, that ARM as in the one who makes the chips or designs the chips that are in all of your phones. In case you didn't know, ARM does have an IoT initiative. We built an IoT platform with Mbed OS and this thing called Helium. If you want to talk about it later on, I'll be around all night, so let's grab a beer and chat. Because a lot of what we've been talking about today, I've got solutions, but because I promised not to make a sales pitch, I'm not going to talk about them now. So, security is the future of IoT. Without security, as we've been talking about all day today, there really is no future for IoT. Because, to be honest, we've been doing IoT for the better part of 20 years already. For 20 years, your Coke machine has been sending SMS text messages back to Coke HQ saying, hey, I've got 5 Cokes left, 4 Cokes left, 2 Cokes left, send me more Cokes. That's been a thing. M2M has been around for a long time. For the last decade, anyone has been able to build their own IoT instance. I know people 10 years ago who were using early versions of Raspberry Pis that were a lot clunkier to automate their homes and do their home irrigation systems. The difference between those systems and what we are currently experiencing with IoT is both scale and then just the best way to phrase it is that IoT is not about controlling things via the internet, because that's been doable for so long. IoT is about doing it at scale in fleets that are manageable, that are updatable in the field, and then taking that data in the cloud and viewing that data and the emergent properties that emerge from massive pools of data using AI and ML to generate extra money based on that emergent properties. So it's not just the data view, it's what the data that informs you that is more than the aggregate sum of its parts, if that makes any sense. Cool. That's the link slide. Good. It's 2 a.m. slide work. So if you want to download these slides, here's the link to the slides. Like any proper savvy evangelist, I'm too lazy to actually download them on a USB drive, so here's a link to SlideShare. Everyone got it? Savvy? Cool. There's also going to be a slide at the end. We'll talk about the slides after. So, as I said, I work for ARM. We've established the whole ARM is everywhere thing. IoT is everywhere. Tons of devices are coming online. A couple billion, a couple trillion devices in the next 10, 20, 30 years. Except in fact, I don't have to go over that for everyone. Cool. So, with that assumption in place, and the assumption that we're going to hit 10 billion in the next 20 years, I think, there's a problem with IoT. And that problem is largely that there's divided knowledge and that hackers are going to hack. These are the two things that are the biggest challenges facing IoT at the moment. When I say divided knowledge, I mean that IoT at the industrial scale that we're observing is different from what we saw before. Because traditional embedded systems that make up the sensor data that's being sent up to the cloud, that's built by electrical engineers. People who go to school to learn how to do PCB design, who learn H-bridges and circuit design. Those people used to design black boxes that would do local control of the physical world via digital processes. Now, in IoT, those people are being asked to then connect those black boxes to the internet and send it out to a web server. On the other side of that, you've got computer science majors who are then being asked to control those boxes and then collect that data and then either graph it or manage those devices or do something. And the problem that we're experiencing right now on the ground is that double E's don't know jack about TCP or how to spin up a Docker container. And if you ask a double E what they're comfortable with, they'll say, a high-level language is C, maybe C++ if you're lucky and they're new. Usually strict C89, ANSI C is where they're at. That's most of their comfortable zone. Low level is assembly. If you're lucky, they say ARM assembly. If you're not lucky, they say like Motorola phone assembly or something else. On the flip side of that, you've got the CS majors who are like, oh, low level for me is Java. That's as low as I go. And it runs everywhere, doesn't it? To which the WE will say, well, Java runs if you have a CPU. If you're running on an MCU, the most memory I have is a megabyte. And usually I've got like at most 256 kilobytes of RAM. You can't run a Java container on that. You can't do a web app on that. And so the very different worlds that they exist in are coming together to form IoT, and where they're coming together and those fault lines between those two worlds are where we're seeing the majority of the problems that are facing IoT today. As everyone knows, that also involves the security of things. Just as my last point to drive home how there's two drastically different ecosystems of people interacting here, When I say full stack, what do you think of? If I say full stack engineer, if you're an embedded engineer, you think PCB design up to C++ API interface that you then hand off to someone else to plug into whatever they're doing, maybe drivers for whatever embedded system you're building. If I say full stack developer to a CS guy, they think backend web server running Node.js plus front end with a little bit of WebSocket in between them to instrument things. Completely different definitions for the same word. And that's a lot of what we're experiencing that then translates into security issues. It's fundamentally, you gotta send information from that device up to the cloud. So, the other half of this that I'm talking about is not just the divided knowledge base, which is resulting in all these problems with security and misconfiguration because both sides don't really talk to each other too well. We also have the issues that over time, your IoT devices have to be updated. This can either be because you have feature releases that you want to push out because you can charge an extra penny per device. So if you have 10 million devices, that's a lot of money. So you want to push out new features every month, every year, every 2 years. Maybe you find a security flaw. Heartbleed comes out and you realize it's affecting the TLS 1.1 implementation you're using and you need to upgrade to TLS 1.2. That can be a very valid thing. You can't predict that at deployment time. Or worst case scenario, hackers hack and half your net goes down and you need to harden the other half of your net and try and recover the other half. These are issues that are going to happen. And so IoT not only has to be secure end-to-end, chip to cloud, it also has to have the ability to update your devices in the field. They have to be recoverable. They have to be ensured that the update works and it doesn't break your device because half of it was corrupted in transit. So you got to verify everything. There's so many things that in IoT could go wrong and that are cross-disciplinary between the cloud guys and the embedded guys. That's why that's why we see all of these hacks happening. And why, to your point, we have password 1234 on so many devices. Because when the W guy talks to the CS guy goes, "Oh, give me a hex 50, was it X501C cert, which is I believe 2 megs last I checked." And the embedded engineer goes, "No, I've got like a half meg of memory. That won't work." And then they agree on password 1234. I can't tell you how many times that has happened, where it's just the lowest common denominator of convenience between the two. So, the solution to these problems of divided knowledge and hackers and needing to have things secure in the end is honestly, you don't ask your developers to think about it. You find a platform that has it built in and is secure end to end that they just have to build their apps on. What we've come to realize, or at least what I've come to realize in working in IoT for the last 4 years and seeing so many different solutions spun up, is you cannot ask even large-sized companies to worry about security because there's not enough security experts in the world. I know like 16 guys in the world that have been traveling extensively for the last 4 years who can do TLS properly. If you ask them to implement TLS and do proper security chip to cloud on the product and you want to hire them, not only are they ludicrously expensive, you're probably not going to get one of those 16 people that I know. Which means more than likely you're going to get someone who doesn't know what they're doing, learns on the fly, and then doesn't implement it correctly, and then you have flawed security. That's how hard this problem is. It's not an issue of finding the right engineer. It's we don't have the talent, and when you do have the talent, you probably can't afford it. So building security in to the platform level, so that when you go to build an IoT device, you don't worry about security. You just go, checkbox, 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 secure chip to cloud. I worry about the application and build on top of the platform that has it built in. That's really the only way to solve it. And we're just now starting to see things emerge around this. I'm not going to mention company names because I am on video and I don't want to have this come back to bite me, but I'm sure you can imagine what I'm talking about. So, because I work for ARM, I am going to discuss this one because I won't get in trouble for discussing this one. ARM does have a solution for this type of thing. If you're not, so who in here does not know who ARM is? Okay, who in here really thinks they know what ARM does, like everything we do? Oh, come on, guys, audience participation. Cool, I'm going to assume worst case scenario then. So ARM has got 2 sides to it. One side is the traditional IP design side. They've designed blueprints for chips, so if you want to make those chips, add a little bit of special sauce to it and release them. We pivoted into IoT 2-3 years ago, depending on how you measure it. With that, we got this whole suite of things. ARM PSA is on-chip security. That means that if someone gets physical access to your device, between TrustZone for Cortex-M and the ARM PSA APIs, if they get physical access and you use these APIs, they can't actually get to your stuff. They're locked down. There's no way for them to override. So the old saying of, if I get physical access, you're pwned, well, I'm sure there's always a way around it, but by and large, no, you're good. Mbed OS is the platform operating system that we recommend using for IoT devices. I'm going to mention that Mbed OS does not necessarily have to hook up to the rest of the thing we're talking about, but it does make it easier. Mbed TLS is what we use for securing connections in transit from device to cloud. Standard TLS, if you've been around the industry for a while, is formerly called Polar SSL. ARM bought them, open sourced them, anyone can use them. I believe it's Apache 2 was finalized earlier this year. And so it's open source, business-friendly licensing. If you want to use it, you can. In fact, all of the other major cloud vendors, again, named, do use Mbed TLS. It's not a us-only thing blocking it. It's more of a, hey, we need to solve this as a platform issue for everyone. Please take this. It's a great solution and use it. And then Pelion is the cloud solution. Again, I can talk about that later if you want. Again, because I'm not promoting the heck out of my own product today, I'm just going to talk about TLS, which is what I really encourage everyone here to think about, because this is how you secure your data from chip to cloud. Without this, you don't have security at all. Now, this isn't all the security you have to worry about. You still have to worry about security on chip. You have to worry about security in cloud. You have to worry about doing firmware updates down the device. That's beyond a 20-minute talk. If we got time at the end, we've got extra slides. You can scroll through later if you want, or we can talk after the event. Point is, who doesn't know what TLS is? Okay, cool. We have enough people that I'm going to explain it real quick. Bear with me and everyone else who is security gods and know what backwards and forwards. So TLS is essentially a tunnel that you wrap around any internet connection, aka a socket connection. When you open up a web browser, you're asking for an HTTP connection, usually in port 80. When you're opening up an SSL, or the port 22, I'm blanking on what that is. Yeah, when you open up an SSH thing to SSH into your server, that's port 22. That usually also gets wrapped in TLS. It's essentially a security tunnel that you send data through. You set it up, you agree with the server using public key, private key, and then everything you transmit in theory cannot be intercepted. That's TLS in a nutshell. It allows you to securely transmit data. Again, open source, anyone can use this. It's on GitHub and it's free as in beer. These are some of the super nerdy details about TLS. The implementation that we have is effectively the latest that you can possibly have. It does all of these things. If you know what TLS, you can see the guy in front here grinning a little bit. It's good, right? Cool. Everyone else who's not super nerdy, it's good. This is what the code looks like. This is what I'm actually really, really excited about. We've managed to make the security on this thing so trivially easy that it's what is that? 1, 2, 3, 4, yeah, 5 lines to implement. Those top 3 lines are just setting up your network interface, saying, here's my certificate, please open it up. Those bottom 5 lines say, wrap this socket in TLS, open it up, use this CA, connect and send data. That used to be like 300 lines of code and a whole bunch of expert config. What we did was we wrapped this in some sensible defaults so that you don't have to worry about how it works, it just works. In case anyone's interested, it's usually like 4 to 6 kilobytes per TLS socket connection, depending on how you configure it. By default, we go heavy hitter to try and make sure that you have the best security possible. You can, of course, scale back depending on what you need to do. So, I've got 5 minutes left because I rushed through that like crazy. I am a developer evangelist, so my job is to be the public-facing pretty boy for the company. I run North and South America and Japan. If you have any questions, please reach out to me on Twitter, find me on LinkedIn, send me an email. I also run our YouTube channel with a bunch of good content. I'm now going to take questions if anyone has any.
Maybe not so much a question, but when you're talking about hiring people to do the code work and everything, I found a good resource with hackathons. Now, the hackathons in the past 2 years have gotten a little bit of a lazy kind of a hacker, but I have found my talent at hackathons.
So you can do that. We've kind of hit peak cap. You gotta go to the events that have like 100K or more prize money to find anyone who's worth showing up for, which is getting harder and harder because a lot of those guys have been snatched up. A lot of my buddies in security have moved to Saudi Arabia recently and are getting paid ungodly amounts of money. Like the kind of stuff that makes Silicon Valley look like peanuts. Yes, sir.
So where are the ARM products that have these features like embedded? Are they like carrying chipsets and XP chipsets? Like, can you give us an idea of where these are sprinkled around so that they go into hardware boards and products and things like that? And also where they tend to lie over on the software side? What sort of open source or generic software that we're all familiar with utilize these things so that somebody can sort of like aggregate, put together and together a solution and ask intelligent questions about where this stuff actually sits.
So, really, how much time do I have? A minute? TLDR, there's essentially two types of, so it depends on what you're trying to do with IoT. In IoT, you can have anything from an application processor like your cell phone or laptop down to an MCU. The vast majority of the long-term IoT growth is going to be in these tiny devices like the MCU in that projector, the MCU in your microwave, the MCU in your power charger. By the way, the charger for your laptop has an MCU in it, or your light bulb or your smart speaker. Those are going to make up the majority of IoT. Those are MCUs or Cortex M-class devices. ARM is going to make up the vast majority of those devices out there. The vast majority of them will be Cortex M. Anything that's Cortex M can play nicely with all of this. The TLDR is, there's an architecture that's coming out right now called ARM Cortex M V8M. It has this essentially root of trust area that we've had forever on, like your cell phone. It has this thing called trust zone on it. It's what the UFI boot in Windows does. It's the secure area where you can store keys. The keynote this morning, the sponsors, I'm blanking on the name, Rivets, that's what they were talking about when they said that they stored it on the chip and in the SIM card. They're storing it in trust zone on the phone. With V8M, we have a similar thing coming to the embedded devices, which enables this on-chip security. As for Mbed OS runs on Cortex M devices, so these small devices. As for Mbed TLS and Helium, those can use with anything, because it's a cloud service and a connection wrapper service.
Right, that's what I was getting at, because I've heard technology presentations like Intel has onboard SDO, and you ask, well, what chip it is, and you give you it's a subset. So I was going here, what's the subset where this is actually there so we can ask intelligent questions about it?
So essentially, this is Cortex M. A different version called Trust Zone is on application classes. This is Cortex M. You run Linux or Windows or whatever else in application processes. These can be used on Cortex M or with Cortex A. In fact, there's a really cool demo with Intel SDO where they run an Intel chip. They use the SDO, they provision it up to Intel, and then they hand it off to Helium to do device management, and they bring it back down. So there's actually cloud integrations between the two services, and so if you like search for the YouTube video, there's a really cool one I think they released last week on LinkedIn, I want to say. Does that answer your question?
Yep.
Beautiful. I think that's all I got. So, yep, I'll be around. Thank you so much.